Welcome to solverfy.
So problem number 44, we're given this reaction, a minus pion plus forms a neutral pion plus a neutron. And it wants us to draw the Feynman diagram, or a Feynman diagram for this. So in order to do that, first we need to look at the quark combinations, like the particle combinations that make up all of these, because we have to figure out the directions and the correlations between the. So let's start with the minus pion. So the minus pion is going to be equal to, it has to have a -1 charge. So it's going to be equal to an anti-up quark and a down quark. So the anti-up quark gives a charge of, sorry, let me pull this table up here. I went away from it. Okay, here it is. So the anti-up quark has a -2/3 charge, and a down quark has a -1/3 charge, so it gives a -1 charge. Baryon number is equal to 0, so -1/3 plus 1/3. Strangeness and charm and bottomness all must equal to 0, so that gives you your minus pion. A proton is going to be a lepton, so it needs to be a baryon. So it has to have a +1. So it needs to be made up of 3 quarks. So we're going to have, and it also has have a positive charge. So we have to have, and also no strangeness, no bottomness, no topness. So it's got to be some combination of the up and down quarks. So it's going to be, if we look, an up, up, down, because an up is a +2/3, another up is another +2/3, and then a down is a -1/3. So this gives you 4/3 -1/3 gives you a charge of 1, gives you a baryon number of 1, and everything else is 0. So that's the combination of a proton. Now a neutron, we've actually already done this. It should be an up, down, down quark. So this was a previous problem, but it's going to have a neutral charge. So 2/3 charge -1/3 -1/3. So it gives a charge of 0. Baryon number of 1. Everything else 0. So that's the neutron. Now for a neutral pion, so the only way to make a neutral pion is an anti-up quark and an up quark combined. So that will give you the correct charge, it will give you the correct baryon number, and it will give you the correct topness, strangeness, and bottomness. So now let's go ahead and draw our Feynman diagram. So we have our reactants up top here. We have a pion and a neutron. So this is going to be an anti-up quark and an up quark. It's going to be a down quark, up quark, down quark. Okay, and then down here we have our minus pion. These are our products. Our reactants. We have a proton. So this is going to be an anti-up quark and a down quark. And then we have an up quark, down quark. All right, so this up quark becomes this up quark, because that's where it can't just go straight up necessarily like that. It's going to be drawn to that particular up quark. Now we have this up quark. Let me draw these arrows here. Then we have this up quark, goes like this to that up quark. And then we have this down quark, goes to this down quark, like that. All right. Now let's look at the final, this guy here. So this down quark is going to be this down quark, like that. All right, now this is an antiparticle, so it's going to go the opposite direction. So it's going to go like this. All right, so this is this is a Feynman diagram, a possible Feynman diagram using for this reaction. Now, like I said, it's possible, so you could have also um, rearrange these and have different some different combinations, but the Feynman diagram basically just gives you which pathways, where the particles go, for conservation here. So where does the quarks go? Which quark becomes which quark, that kind of thing. So there are other possible combinations, but this here is one of them.